Hello and welcome back to the class, R for Journalists. We are now going to dive into the basics of R. The one thing you must realize is that R is a programming language, and so syntax is very particular. You must be very specific, it must be exact for R to work. It won't guess for you. So R is a case-sensitive interpreted language. You can enter commands at this prompt by the caret. And let's say help. That is a command. If I want, I can precede it with this hash, and that means it's commented out. It will not run the code at all because R recognizes that. This is important to use often in your code for documentation. You'll see it often throughout this course. That just means right here, that's an example of a comment. If it's grayed out, you should always kind of pay attention to that because I'm trying to pass on some extra context and messages to you on how this is working. That's also documentation in itself. So working directories is the folder on your computer in which you are currently working. When you ask R to open a certain file, it will look in the working directory for this file. And when you tell R to save a data file or figure, it will save it in the working directory wherever you tell it to go. So before you start working, please set your working directory to where all your data and script files are going to be stored. I am going to create a new one. Oh, I have one here called R Journalism. So I can to see where you are right now, what your working directory is, type in get wd parenthesis, and I am currently in documents. But as you can see here, nested in the carets, home, documents, R journalism. So I want to set wd is the command to set working directory, and in quotes, I'm going to type in tilde / documents / R dash journalism. Okay, and you see it kind of change up here as well. So now when I type in get wd, I am now in the correct directory. I am in this directory. There's nothing in it, but that's fine. In a PC, your set directory might look like this. C:/ / documents R journalism. So this might look different. Might be looking different to how you would go to a directory in your PC. Usually it's this, right? / a backslash in R means an escaping of a character in a string. We'll get into that later, but you should always know that you should use / in a PC. And also don't forget your quotation marks. So within R, you can also set your working directory via the tools up here. Go to the menu, go to session, you can click set working directory, and you can choose manually the directory here. Click open, and it pretty much will translate that into a console command for you. You can also set it to, I'm going to go back to documents, and session, set working directory to files pane location. And because I am currently in the documents directory, when I click this button, it'll now set working directory to that. So working directories are a tough concept. It's part of the best practices in chapter 6, which we'll be going over in more detail. Pretty much what I will tell you and that give you a preview is don't set your working directory this way. Always set it relative to your project. We'll get in that later. For now, let's talk about libraries now. So R can do many statistical and data analyses. They are organized in so-called packages or libraries. And you can do a lot of statistical analysis in R without any additional libraries. This is called base R. But others have created libraries with functions that solve common problems. R package users download only the libraries that they need for an individual project. So to get a list of all installed packages, go to the package window here, click on that tab, and you can scroll down, and this will show you the check marks represent what is currently loaded into your memory and it's accessible. The rest of them are currently installed on your computer. So that means if I type in library, then that's the command to bring in a library is library and then httr. It loads there in the background. If I loaded a library that I don't have, let's say this one, it would say that library doesn't exist. To install a package or a library, you type the command is install.packages. And these are libraries and packages that other people have created. Let's say I'm going to install dplyr, which is what we're going to be using in the next few chapters to wrangle data with. Sometimes you'll get this, you've already got this package, do you want to restart? Go ahead and click yes to restart the session, and then when you load it up again, it should work. And now when I type in library dplyr, it is now loaded. If you see some warning messages, that's fine. It might mean I need to update my software, my R software. But as long as it doesn't give you an error, it's just a warning, you're fine. So let's deal with some more commands in R. So R can be used as a calculator. You can do some math in it. I mean, statistics and all, right? So you just type an equation into the command after that little caret in the console. So for example, 10 to the power of 2 plus 26 equals 126, and it gives you that little output next to that 1. So this is the workspace, and you can give numbers a name, as in you can assign numbers to an object, which can be like a letter. A is the object, and I'm going to assign it to 4. So now it's there in my global environment, and when I type A, it knows that it's a 4. And you can do calculations with that object now because it understands it's a 4. So I can do A plus 5, and that equals 9. If I assign anything to A again, it will forget that was ever a 4. It is now a 3. I can also assign a value to A using the old one. So A is A plus 4. So that means 3 plus 4. And so now A is 7. To remove all variables from R's memory, type in rm list equals ls. Or you can click this little broom up here. This is useful if you're trying to clear things out, maybe clear up some memory. Next, we're going to talk about scalars, vectors, and matrices. So what I had here, A is 4, that was a scalar. That's like a single number or a single character or string. Vectors are more than one of those things. So like a row of numbers. This is also known as an array. So it's like two-dimensional. And then there are matrices, which is like a table. So let's say the A was scalar. Vector. Let's create a vector that's more than one string. More than one number. 3, 4, and 5. There it is in the environment. B is now 3, 4, and 5. Now if I wanted to find the average of it, just you would do this 3 plus 4 plus 5 in parentheses, of course, because it's math, divided by 3. The average of those 3 numbers is 4. Now, what if we had a long line of numbers, thousands of numbers, and we want to find the average? That would be horrible to have to type out by hand, right? So you would want to use a function that would find the average. So functions do things to data. R is built on them. Some functions come with R, like median, or let's try median on B, or summary, and others come as part of the packages that others have created. When you use a function to compute an average, you'll type mean and then x equals b, or you can because it's implicit that x will equal that whatever you give it. So I can either type x equals b, or I can type mean b. So within those parentheses of the function, you'll specify arguments. So arguments give extra information to the function. In this case, the argument x says of which set of numbers, which is the b vector, should the average be computed, and that's b. Sometimes the name of the argument is not necessary. Like I said, you can just do mean b. That also works. So let's talk about another kind of base function to visualize data, and that is plot. First, I'm going to create a new array of numbers using the function rnorm. So I'm going to assign it to x, rnorm 100. And what that did is it created 100 random numbers and assigned it to the variable x, which becomes a vector by this operation. And now I can use the function plot, pass it the x, and I come up with a cool plot. So you see the x is the where it is in the in the array, and then you got the digits, which is 0.6, -1, etc. Okay, last thing I want to talk about in this particular video is the concept of scripts. So R is an interpreter that uses a command line based environment. This means you have to type commands rather than use the mouse and menus like you would in Excel. This has the advantage that you do not always have to retype commands. You can store your commands in files, the so-called scripts. These scripts have typically, they end with the file extension .r. Another way to script your code is R Markdown, right here. This is a way to interweave R code plus Markdown code, so you can like build up a narrative. This is like the notebook style that you see in like Python and Pandas and stuff. So to create a new script, you just click on this little green arrow and get the R script, or click on File, New File, R script. So let's bring in the code that we've created before, X. I'm going to copy this up, save it to move it up to the script. You can also go to your history and scroll through all your commands that you've created. And I'm going to, there it is, plot. So you just click on the line and click on to source, and then it brings it over to source. You can also click to console if you want to rerun it that way. And now I'm going to save all this code that we've got. Save it as script.r. And let's see, where's my working directory? Get WD. Okay, I need to set the working directory to this documents folder again, so that when I run the script, because if I tried to type in the code for script, it would look for it in this particular folder, which is not correct. So I need to go to session, set working directory, to file pane location. So now I'm back in documents where I should be. To run this script that I've saved here, I just type in the function source, and then quotation marks, and the name of the script, script.r. And let me clear this out just so you can see what happens. Clear out the environment, clear out the plot view, and now when I type this, it ran both of these lines of code. It created X, an array of numbers, and it plotted out the numbers. So this is the first step in reproducible analysis, data analysis. Alright, so we've gone through a lot of basics in R. We talked about syntax, we talked about working directories, we talked about packages and libraries, and I showed you some examples of commands in R and how to do some math, and also the idea of scalars, vectors, and matrices, and an introduction to functions. So next we're going to talk about missing data and classes of data and more about libraries. So I'll see you then.